right, so here we are continuing with identities. So the sixth guideline or commandment of doing identities is if you can distribute something, try distributing it. So in this identity, we have the cosecant times 1 minus the cosine of x, cosecant squared and cosine squared equals 1. So I'm going to distribute that and see what happens, multiply it out. So I get cosecant squared of x minus cosecant squared of x times the cosine squared of x equals 1. All right. So we got two terms on the left and then just a 1 on the right. So you probably want to use a Pythagorean identity because we have a lot of trig functions squared. So what I'm going to do is rewrite cosecant as 1 over sine. And I'm going to leave this for now. I mean, if you're doing this on your own, you might have thought, oh, let me just change that to 1 over sine. And you could, but you'll see that you're going to want to change it back. Because with your Pythagorean identities, all right, if you're looking at home, I'm going to pull up the Pythagorean identities. You have sine squared plus cosine squared equals 1, 1 plus tangent squared equals secant squared, and cotangent squared 1 plus, cotangent squared plus 1 equals cosecant. So since we already have cosecant, if we could show that this is cotangent squared, then we could use that third Pythagorean identity. And this is cotangent squared because this part here would be cosine squared over sine, over sine squared. So cosecant squared of x minus cosine squared over sine squared equals 1. So that's going to be cotangent squared. And we don't want to cross an equal sign. So you don't want to add cotangent squared to both sides because we can't assume that both sides are equal. Now, if we look at the Pythagorean identity with cosecant squared and cotangent squared, we have, I'll write on the side here, cotangent squared of x plus 1 equals cosecant squared of x. Now, that's pretty similar to that, but we need to just then, this we can assume is true because we're using, it's one of the 8 fundamental identities. We can use it, we can assume it's true. So we can manipulate this. This could be written 3 different ways. I'm going to subtract cotangent squared on both sides. And now I just showed cosecant squared minus cotangent squared equals 1. So now we could substitute this, we could substitute in 1. So then we get 1 is equal to 1. So we just proved that that identity is true. Any questions? All right, so let's try it again. So there's another example here in the slides on slide 21 that says if you could distribute something, try distributing it. So it's cosine squared of x times tangent squared of x minus secant squared of x equals negative cosine squared of x. Now, one of the rules or guidelines that I suggest is to always start on the more complicated side. So I would definitely say that's the left side. So I'm going to distribute the cosine squared on the left to start. So I get cosine squared times tangent squared equals cosine squared times secant squared. And that should all equal negative cosine squared of x. Now, you don't really have to keep writing out the right side if we're only manipulating the left side, but it doesn't hurt. All right, now I'm going to put tangent and secant in terms of sines and cosines to see if it simplifies to something else. So I get cosine squared times sine squared over cosine squared. That's what tangent squared is. And then minus cosine squared times 1 over cosine squared. Now, these will both simplify. If you notice, these cosines will cancel out because now this is just like one fraction. So cosine squared over cosine squared is equal to 1. So this just becomes sine squared of x. And then here, cosine squared over cosine squared is going to cancel out. And you get a -1 equals negative cosine squared of x. And you can probably see that this is the Pythagorean identity, but resist the urge to like add cosine squared on both sides and add 1 on both sides. Because again, you're not allowed to do that unless you know this is true. And we don't know it's true. We're trying to prove that this is true. So on the side, maybe write the Pythagorean identity you want to use. And it's going to be this one, sine squared plus cosine squared equals 1, because we have sine squared and cosine squared. Then we want to manipulate this by subtracting cosine squared on both sides, and then subtracting 1 on both sides. So we just showed that sine squared minus 1 is equal to negative cosine squared. And now we can just substitute that in. And we get negative cosine squared equals negative cosine squared. And there you go. So that's your 6th guideline. All right, if you could distribute something, try distributing it. All right, and now the opposite of distributing or multiplying is factoring. So now we're going to try our 7th guideline. If you have a difference of 2 squares, try to factor it. So this is now slide 21. The 7th rule is try factoring dots, which means difference of 2 squares. So if you have 2 perfect squares, like a squared minus b squared, that could be rewritten as a minus b times a plus b. So the identity we're going to try to prove is tangent squared of x minus cotangent squared of x. Oh, I can't write. Sorry. Over, so ignore that, over tan of x minus cotan of x is equal to cosecant of x times secant of x. All right, so tangent squared of x minus cotangent squared of x over tan of x minus cotan of x equals cosecant of x times secant of x. So this right here in the numerator, ignore this ugly blob here, is factorable because it's a difference of 2 perfect squares. So it means we could factor it as the tangent of x minus the cotangent of x times the tangent of x plus the cotangent of x, all over the tangent of x minus the cotangent of x, equals cosecant of x times the secant of x. Now, if you notice, we got something that cancels out here. So we're going to simplify it because this left side is way more complicated than the right side. So by simplifying it, we're making the left side look more like the right side. So we cancel that out. And we get the tan of x plus the cotan of x is equal to the cosecant of x times the secant of x. Okay, now we're going to go back to one of our other strategies. And this actually might be a proof that we did already. It sounds familiar. But on the right side, we have one term. We have 2 things being multiplied, nothing being added. So we have one term here. On the left side, we have 2 terms. So you can either take the right side and break it apart and write it as 2 things being added, which is harder to do, or try to get a common denominator on the right side and then rewrite that and then, write it as one fraction, and then it should, as one term, and then it should simplify to that. So to get a common denominator, because I know cosecant is equal to 1 over sine, and secant is equal to 1 over cosine, all right, I'm going to rewrite these in terms of sine and cosine. And I equate that to like a cheat code, all right? Identity is like a math problem where you know the initial step and you know the final step, and you have to fill in the blanks. So cheat, like take a peek at what the final step should be. All right, this should end up being cosecant of x times secant of x. So when you're on a step like this, you think to yourself, how can I make this more like cosecant and secant? And think, all right, well, what's cosecant and secant? Well, that's 1 over sine, that's 1 over cosine. So I should try to put this in terms of sines and cosines. All right, so use that to your advantage. Like you have the first step, you have the final step, you just have to fill in the middle, which is easier said than done. It's kind of like that's why I kind of equate it to proofs in geometry, where you're like given something and you're given what you're trying to prove, you just have to like fill in the middle. So to get a common denominator, I'm going to multiply the left fraction by sine of x over the sine of x, and then the right fraction by the cosine of x over the cosine of x. And then I get sine squared of x plus cosine squared of x all over sine of x times the cosine of x. And we're trying to make that look like cosecant of x times the secant of x. And you might think to yourself, well, we just made this more complicated, and you're right. But at least now we have it as one term, like one thing being added, although we have a sum in the numerator. But notice that that sum is a Pythagorean identity, which means we could probably substitute something. And that's like the most common Pythagorean identity, sine squared plus cosine squared. And we know that equals 1. So we could substitute that in. And now it's starting to look more like the right side because we have 1 over sine and 1 over cosine. It's just not written like that. But 1 is a factor of any number, especially 1. So we could factor this as like 2 separate fractions. And then 1 over sine of x is equal to cosecant of x, and 1 over cosine is equal to secant of x. And that's what we were trying to prove. All right, and I get that I'm making this look easy because I'm walking you through it, and you're going to try these on your own eventually and be like, this is really hard. Some of you may think that, but just be relentless. Like if something doesn't work, try something else. Look at these guidelines, all right? And you always go back to the 8 fundamental identities. Like look at the left side, look at the right side and think, okay, what can I substitute in here to help me? And if you ever see a trig function squared, look to your Pythagorean identities. All right, we'll practice this a lot too. All right, so why don't I give you a chance to try one on your own? So the next one is the same strategy. You're going to try to factor. So we have, I'll give you a couple minutes to start it, and if you prove it, that's great. But if you get stuck, we'll see where you got stuck, and we'll go from there. So cosine to the 4th of x minus sine 4th of x over cosine squared of x equals 2 minus the secant squared of x. All right, so give this a shot. This is on slide 22. All right, you have a difference of 2 squares. They're both to the 4th power, but something to the 4th power is a perfect square. So I would suggest starting off by factoring this and then see what happens. All right, so first step, when I see this difference of 2 squares, I would factor the numerator. Now, does anyone want to share, did anyone do anything after that step? Yeah, Hayden? You want to be careful with that because they're not factors. Like, it's cosine squared minus sine squared. if it was like cosine squared times something else, you could do that. But you don't want to cancel out terms. Like if you had like 2 plus 3 over 2 plus 8, right? That should equal 1/2. But if you cancel out these terms, then you get that. So I think of it as like, if I have a fraction and I multiply the numerator and the denominator by the same number, it's going to stay the same. Like 1 over 2, if I double it, I get 2 over 4. If I triple the numerator and denominator, I get 3 over 6. That's all 1/2. But if I had like 1 over 2 and I added 1 to the numerator and denominator, I would get 2/3. But we're going to cancel eventually. Anyone else see anything we could do? Yeah.
Cosine squared plus sine squared is 1.
Yeah. Nice. Cosine squared plus sine squared is equal to 1. So anytime you see trig function squared, I would look to your Pythagorean identities and see if you see one that you could substitute. So you could plug 1 in for that, and it just kind of disappears because it's 1 times something. So now we have cosine squared of x minus sine squared of x over cosine squared of x. And we want to show that that's equal to 2 times the secant squared of x. Does anyone see what we could do next? So if you look at the right side, you have 2 terms. Yeah. You could, but, and that's not wrong. I'm a big proponent of just working on one side and try to make it look like the other side. I equate it to like, let's say you're lost in the woods and someone's looking for you, all right? Is it better to stay in one spot or move around? It's a debate we can have. In my opinion, if someone's searching for you, like if they're combing that area, I would stay in one spot. Because then, if you're in one spot and someone just like does like, all right, a clean of the area, like, all right, I'm going to go down this way and this way, they're eventually going to find you. But if you're moving around and they're moving around, they might come to the spot where you once were and you'll never see them. So the point I'm trying to make is if you start working on both sides, then you might eventually make the left side look like what the right side once was, and you might not notice it. That's a philosophical thing. You could go for it, but in this particular one, you have this 2 here, which I think might bring you issues, because if you're gonna do that, then you're gonna have to like change that 2 to a 1 plus 1. It's not a black and white thing. But I see a clear path by just looking at the left side. And what I want to point out is that the right side has 2 things being subtracted. This is like 1 fraction. But let's try to break this up as 2 things being subtracted. It's all over the same denominator. So we could break this up as cosine squared over cosine squared minus sine squared over cosine squared. And we want to show that's equal to 2 minus secant squared. So now we could simplify these. We could rewrite these. We could rewrite cosine squared over cosine squared as 1 and sine squared over cosine squared as tangent squared. And it's starting to look more like this. It's a little different. But again, when you have trig identities that are squared, when you have trig functions that are squared, look for Pythagorean identities. So now what I would do is try to express tangent in terms of secant. And if we look at our 8 fundamental identities, specifically the 3 Pythagorean identities, the second one is 1 plus tangent squared is equal to secant squared, which means if we subtract 1 on both sides, we get tangent squared is equal to secant squared minus 1. And Now you could substitute in secant squared minus 1 in for tangent squared. And that's where the 2 is going to come into play. All right, we get 1 minus parentheses secant squared minus 1. And if we distribute that negative sign, there's your 2. 1 plus 1 is 2. And there we go. That's not the only way to do it. You could have changed secant squared to 1 over cosine. I'm just trying to show you how I'm thinking about it, because again, this is not black and white. So I'm trying to show you like different cues that help you do different things. So when I see here 2 things being subtracted and here like 1 fraction of a difference, I'm going to break this up as 2 things being subtracted. Then this is in terms of secant. So I'm going to rewrite these, in terms of tangent and 1. And then, oh snap, it's a Pythagorean identity. Whenever you see a Pythagorean identity, look towards the one that has that trig function in it and substitute. And it just so happens that tangent could be written in terms of secant, or tangent squared could be written in terms of secant squared. And it just simplifies. And it should simplify, because I'm not going to intentionally give you an identity that doesn't work. So use that to your advantage. All right. Assume that this should equal that, and take a peek at that and ask yourself, how can I make the left side look like the right side? Well, I'm missing a secant, so let me see if I can replace tangent with something in terms of secant, and everything else should take care of itself. All right. Let's see, let's do one more. So another method to try. So let's see, 22. Slide 23. This will be the last one for this video, and then I'll tell you what you could do for next class. All right, this is slide 23. So number 8, the 8th commandment of proving identities. If you get stuck, convert everything to sine and cosine. So that's because sine and cosine obviously could be written in terms of sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. So all trig functions can be written in terms of either sine or cosine. So if you do that, then it might help you see what to do. So we have tan of x plus cotan of x is equal to secant of x times the cosecant of x. So I would say this is like a last resort, but it is a resort, right? It's nice. Airfare's cheap because of the pandemic. It's a beautiful resort. So, and I know I'm about to contradict myself, be a hypocrite. I said, don't work on both sides, but as a last resort, you can work on both sides and convert everything to sine and cosine. Just don't cross an equal sign. Like, don't multiply both sides by something. Don't add something to both sides. You have to just manipulate both sides without crossing the equal sign. So that means you can't do the same thing on both sides. You could substitute something on one side or something else on the other side. All right, so here's what it would look like. Sine of x over the cosine of x plus cosine of x over the sine of x is equal to 1 over cosine of x times 1 over sine of x. So you see, all right, that's kind of, they're starting to look a little bit more like each other, the left and right side. All right. And now I see on the left side, I have 2 things being added. On the right side, I have 2 things being multiplied. So in order to make the left side look more like the right side, I want to get a common denominator here and see if it could be simplified to that. So I think we've done this before. We're going to multiply this first term by sine over sine. We're going to multiply the second one by cosine over cosine. And we get sine squared of x plus the cosine squared of x over sine of x times the cosine of x. And I would just leave this b for now. You don't want to go, like I said, it's like looking for someone. Maybe let's not go with the woods. Let's go supermarket. Let's say you lost your mommy in the supermarket and you're stuck in the candy aisle because you drifted away. You saw the Snickers and you're like, I want that Snickers. And then you look and your mom's gone. The worst feeling. All right. Even as a 31-year-old man, when I lose my mom in the supermarket, it is just terrifying. So what I do is I stay in that aisle because I know if I start wandering around all the aisles, my mom might come to where I just was. If I stay in the candy aisle, my mom eventually gets to that aisle, I'll be there. So if I'm roaming around with this side, I don't want to, is my analogy making sense? Is it? I think it makes sense in my brain. All right, I want to just keep changing this side until it looks like that. All right, I don't want to change both sides because then you might eventually make that look like that and that look like that. And then it's like the Spider-Man meme where you're looking at each other. You're like, it's the same thing, but you changed it. All right, there you go. That made sense. So, all right. So now I'm going to take this and change it as 1 over sine of x times cosine of x is equal to 1 times cosine of x times 1 over sine of x. And now we're pretty much the same thing. And if you stop there, I would be okay with it. But you could just like write that as 1 times 1 and then just like flip it around because you can multiply anything in any order. And then bada bing, bada boom, we're done. All right, so that is the 8th guideline of proving trig identities. So next class, we'll have one more live lesson tomorrow. We'll finish these notes. And then for today, you're gonna do some, so you're gonna go to the 3.2 Proving Identities Day 1. And there's a PDF there. And I said to do the first page, the evens. Did I say the evens or the odd? The evens. So 2 through 22, I should have said. Now the ones that we did would take a little longer. So I don't think these will take that long. So that's why I feel comfortable assigning 10 of them, especially that you have 15 minutes right now in class. But if you get stuck on one for more than like 5 minutes, just skip it, circle it, and ask about it tomorrow. All right? So if you have any questions on the homework that was due today, please let me know right now. If not, you're free to get working on the homework or leave the Zoom. Yeah, Hayden? No, they didn't. Really? When? Just now? No. What about baseball season? No. Just cancel rest. Just cancel other sports. I guess we'll have to play around. No, I think they've planned for this. I think it's like they're gonna do it like from May to June, or it's gonna be 6 weeks of wrestling. Let me pause the recording because when someone's watching this in like 2023, like what the hell are they talking about? All right, stop.